Hello and welcome to Main-iac Science Lab. I'm Mr. Andy, Youth Services Librarian at Main Library here in St. Augustine, Florida, part of the St. Johns County Public Library System. And today we're going to have some fun with science. In fact, we're going to go back and do one of my favorite experiments that we haven't done in a very long time, about a year to be exact, and it's called polymers. We're going to make what you may already know of as goo or slime, but it's actually scientifically a polymer. And I'm going to show you how to make it with household ingredients. It's super easy, it's super fun, and it's a good time. And you're going to learn something in the process. So, to make your polymer, you only need a couple of things. I'm using a baking sheet. That way I don't get stuff on my countertop because I like my countertop and I want to keep it clean. A clean workspace is always a good thing. So I recommend you use a cutting board or a baking sheet or some sort of protective mat to protect the surface that you're working on, because we are working with chemicals and we're going to be working with dyes as well. The number one ingredient you're going to need is plain white school glue. Any plain white school glue will work, but it seems Elmer's seems to have the chemical compound that seems to work the best, at least in the experiments that I have run so far. But any school glue will work. You need 4 ounces of white school glue. You'll also need a little bit of contact lens solution. You'll need some baking soda, a measuring cup of some sort, or a stir cup, etc. Something to stir with. Today I'm just going to use a fork. You'll need some measuring spoons so you can measure out some things. And if you want to have a little extra fun, some food coloring to color your polymer, just to make it a little more interesting. Okay, super easy. So what is a polymer? Well, a polymer, somewhere in between a liquid and a solid. It's not a liquid because it holds its shape, mostly. It's not a solid because it's squishy. That's probably the easiest way to recognize what a polymer is. If it's squishy, not, because say you have some water, and you drop it on the countertop, it's going to disperse everywhere, it's going to break into little droplets, very easy to take apart. If you have a solid and you drop it on the counter, it's just going to go thunk and it's going to stay there. Because a solid has solid molecules that are very tight together, making it a very strong bond. Liquids have liquid molecules that are very loose, very easy to break apart. Molecules and polymers chain themselves together. So they can be pulled apart, but they still stay connected. It's pretty cool. Chewing gum is a common polymer because it's stretchy and bendy and you can do all kinds of stuff with it. Tennis shoes, the sole of your tennis shoe is a polymer. Rubber bands are polymers. There's a lot of different polymers in the world. You can probably look around your house and find quite a few. Pretty much anything that is fairly solid but bendy and stretchy. That is a polymer. So let's go ahead and jump right into making one. And I'm going to take my measuring cup here. You're supposed to work with 4 ounces of glue for this particular recipe. I don't have a 4-ounce bottle. They come in 4-ounce bottles. Mine is a 7.625 ounce bottle. So I'm going to put in 4 ounces into my measuring cup. That way I still have my 4 ounces of glue. And because glue takes forever to squirt out, I'm going to go ahead and take the cap off and just goop it in there rather quickly, so you don't have to sit here and watch me gooping in glue. Wow, that's pretty close to the whole bottle. That seems like a lot. But my measuring cup says 4 ounces, and it calls for 4 ounces of glue, so we're going to go with that. So, next we need some contact lens solution. No, I'm sorry, I'm jumping ahead of myself. Next we need baking soda, about a half tablespoon. So find your half tablespoon measuring spoon, measure out a half tablespoon of baking soda, and be careful when you're measuring this because sometimes it clumps up. I'm going to go ahead and do the measure over the counter, over the bowl, just in case I spill a little bit, which I did. And we're not wasting it. We're just adding a little extra in there. So once you throw your baking soda in there, then you want to mix and start stir, 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 just stir, stir, stir. Stir it all up, stir it all up. Have a good time stirring. And when it's good and stirred up, then if you want to, you can add a little bit of food coloring. But we're working with chemistry here. So every ingredient is going to change the chemical makeup of the final product. The choice of glue, the choice of contact lens solution, the choice of baking soda, well, baking soda is baking soda. But when you add food coloring, you're altering the chemical makeup of your final product. So be very careful with your food coloring. Don't use too much, just enough to tint it. In fact, I recommend doing this without the food coloring and then doing it again with the food coloring so you can see the differences in your recipe and see how it's altered. So I put one drop of blue food coloring in here. So it's going to give my goo a blue tint, my polymer. It's going to have a very blue tint. It's a little smurfy. So once that's all mixed up good, we're going to add 1 tablespoon of contact lens solution. Regular multi-purpose solution, not the crazy overnight cleaning stuff, but just a regular multi-purpose solution. So 1 tablespoon of that. Get your little measuring spoon, measure it out, put it in. And when you add this, that's when things are really going to change, and rapidly. Are you ready? Here we go. We're going to put that in, and we're going to mix, and then almost instantly, your glue is going to begin hardening. Look, I can actually lift it up with my spoon. There's our goo. Keep on mixing, mix it up real good. Oh goodness, now it's like stuck to the fork. Wow. All right, so now when you start getting a good solid clump of goo like that, which is pretty awesome, now you can take it out of the bowl or cup or whatever you're stirring in and place it on your surface. And it's gonna start, you can start kneading it like you would bread dough. Oh wow, here we go, it's really going now. Look at that. 1 solid piece of goop, which I'm just gonna drop onto my surface. Wow, look at it stretching and bending and pulling. Those are those polymer molecules chained together, but moving around. Now this is super sticky. If it's too sticky, and this one's super sticky, you can actually add a little more contact lens solution to make it a little less sticky. So I'm just going to pour it right on there, just a little, and then just kind of fold it over it. Let's put some on the bottom and the top too. Smooth it around, flip it over, smooth it around. It becomes a lot less sticky. It doesn't stick to your fingers like it did before. So if yours is too sticky and it's sticking to your hand and you can't get it off, add a little bit more contact lens solution and that'll take care of it. So now when you got it on your surface, you can play with it. You now have a polymer. So I recommend letting it sit on your surface for just a minute. Let it continue its baking. And then you can form it into different shapes and have some fun with it. So let's say I'm going to make this into a tower of goo, and then you just watch it, and it just melts into a puddle of goo. And you can have fun with this for hours, just playing with it. It's silly, and it's fun, and it's goofy, and it's science. So we know that a polymer is loosely chained molecules that are bendy and stretchy. Question is, how bendy and stretchy are they? So when you're ready to start experimenting with yours, and I think mine's ready to go, it looks pretty good. Yeah. So pick up your goo, hold it in your hands, and then very quickly pull it apart. It snaps in half. But if you smush it all back together and try it again, but this time go slowly, it will stretch and stretch and stretch and stretch and not break apart until it gets too skinny in one spot. Oh boy, it goes really far. And then it may eventually break if it gets skinny enough and the weight of it is too much for it. But this one didn't break at all. It just kept on going. And then you can take it and you can wad it all back together, squish it back up just like bread dough, and keep on playing with it. So what can you do with your polymer besides just squish it in your fingers all day long and be goofy and silly and a little gross? Blah. You can do things with it. You can have fun. You can make a little bounce. It does kind of bounce a little. See? It's a little bouncy. If I made a smaller one, whew, it'll probably bounce a little better. So roll it up to a ball. Boing, boing. You can stretch it. You can make like a big goo mustache or smiley face. Don't get it in your hair. Not a good idea. Also, word to the wise, parental figures who are supervising the science experiment. Do not let it get on the floor, especially if you have carpeting. It's still essentially glue. So, if you let your kids play with it on a surface or a countertop, all is well in the world. But if they take it and they drop it in the carpet and maybe step on it, it's going to make a mess and it's going to be really hard to get out. I do apologize, but I am teaching you this from experience with my own children. So, you now have a polymer that you can play with and do silly things with. One class that I led with this, I had them take their polymer and see how far they can stretch it into one solid strand. And I had kids who were able to stretch their single piece of polymer over 6 feet long, which is amazing. In fact, the table they were working on was not long enough to hold it all, so they were stretching it and then looping it back and forth across the table to see how far it could go. And we had to get the measuring tape out to measure it. So that's a lot of fun. You can also just make a wad of it and hold it in the air and see how long it takes for it to stretch all the way down to the bottom. That actually didn't take very long at all, but it's still stretching, see? It's still going. And then if you're creative, you can make designs out of it. Make a smiley face. Well, you can't really make a smiley face without breaking the chain. But what can you make with it without breaking the chain? You know? It just keeps on stretching and stretching and stretching. Hours of entertainment and fun and goopy slimy mess. So, that is how you make a polymer using simple household ingredients. I hope you enjoyed it. I hope you have fun. I hope you don't make too big of a mess. Experimenting should make a little bit of a mess, but try to keep it under control so mom doesn't have to go crazy trying to scrub the carpets. And that has been another episode of Main-iac Science Lab. For the St. Johns County Public Library System, I'm Mr. Andy. Happy to see you. Come visit me at Main Library sometime. I'm usually hanging out in the children's department there. I'd love to talk to you. I'd love to show you some of my science books so you can learn some experiments on your own. And keep learning, keep experimenting, and keep having fun. For the St. Johns County Public Library System, Mr. Andy, signing off. Have a great day, guys.